Welcome to Apex Science Academy. In this video, I will go over the active rotation problem we posted last week. To solve this problem, you need to be familiar with two things in trigonometry. One, the definitions of sine and cosine functions. Two, the sum identities of sine and cosine functions. Now let's look at the problem together. So this problem starts by defining an active rotation, which is a transformation that physically rotates an object while keeping the coordinate system unaltered. This is in contrast to the other rotation in physics, which is called the passive rotation. It's a transformation that physically rotates the coordinate system while keeping the object unaltered. Active transformations are commonly used in physics, particularly when the physical orientation of objects in space is important. So in this problem, you will investigate an active rotation of a straight arrow line in the XY plane. Let A denote the point 1/2 and 1/2 of square root of 3, and O denote the point 0, 0 in the XY plane. OA is a straight arrow line pointing from O to A. Suppose OA is rotated counterclockwise around the point O by 90 degrees to produce a new straight arrow line, OA prime. So we need to solve two problems. In part one, we need to determine the X and Y coordinates of A prime, which is the tip of A prime, OA prime. In part two, we need to determine the X and Y coordinates of A prime if OA now is produced by rotating OA counterclockwise around the point O by an arbitrary angle alpha. So since part one is a special case of part two, we will just focus on determining the XY coordinates in part two. So once we have determined the XY coordinates for part two, we can simply replace the angle alpha with 90 degrees to produce the XY coordinates for part one. So this looks like a rather abstract problem. And how do we solve this problem? Well, to solve this problem, we need to draw some diagram to help us visualize the problem. So let's flip to the next page. What I have here are the two lines, OA and OA prime, in the XY coordinate system, XY plane. So let us assume that the XY coordinates for A are X and Y. The XY coordinates for A prime are X prime and Y prime. For now, we're going to assume that the angle between OA and the positive x-axis is theta. Now, since OA prime is obtained by rotating OA counterclockwise by an angle of alpha, the angle between OA prime and OA is alpha. And then as a result of that, OA prime and the positive x-axis will make an angle of alpha plus theta, or you can say that the angle between OA prime and the positive x-axis is alpha plus theta. Now, from the course of trigonometry, we learned that for angle theta, we can define its cosine and sine function using the coordinates of A and the length of OA as follows. Cosine theta equals X divided by R. Sine theta equals Y over R, whereby R is the length of OA, which is the square root of x squared plus y squared. Now, we can rearrange these two equations to express the xy coordinates in terms of r and theta as x equals r cosine theta, y equals r sine theta. So what these results tell us that you have another way to express the position of A. Normally you would use the XY pair to denote the position of A. But what you notice here is that you can also use R, the length of OA, and the theta, the angle between OA and the positive x-axis, to independently or to alternatively express the position of A. Now, similarly, let me write it here, for the angle of alpha plus theta, we can write down its cosine and sine functions using the coordinates of A prime and the length of OA as follows. Cosine alpha plus theta equals x prime over r prime sine alpha plus theta equals y prime over r prime, whereby r prime is the length of OA prime, that is x prime square root of x prime squared plus y prime squared. Now, since OA prime is obtained by rotating OA counterclockwise by an angle of alpha without stretching, the length of OA prime must be equal to the length of OA, which means R prime is equal to R that we obtained here. Now, using these three equations, we can express x prime and y prime as x prime equals r prime cosine alpha plus theta equals r cosine alpha plus theta. Y prime equals r prime sine alpha plus theta equals r sine alpha plus theta. So let me box this result. So now we're in position to actually write down, determine the value of x prime and y prime, which would require us to further expand this term and this term using the sum identities of cosine and sine functions. We're running out of space here. We're going to do this on the next page. What I'm going to do is to copy this and paste to the next page. So we're going to first do that for x prime. So x prime equals r cosine theta plus cosine alpha plus theta, and using the sum identities of cosine functions, we have cosine alpha, cosine theta minus sine alpha, sine theta. And this can be further written as cosine alpha times r cosine theta minus sine alpha times r sine theta. So what are these two terms? Remember from the previous page, we have these relationships. It's x and y. The xy coordinates of A can be written in terms of r and theta. Let me just put it here. So now from that relationship, from this relationship, we're going to replace our cosine theta with x, which is the x coordinate of A, and r sine theta with y, which is the y coordinate of A. So then we can write x prime equals cosine alpha times x minus sine alpha times y. So get an expression. Now we get an expression for x prime in terms of alpha and xy. So now we're going to do the same thing for y prime. So y prime, we start from y prime equals r sine alpha plus theta, and then we're going to use the sum identity of sine functions. Then we can write sine alpha cosine theta plus cosine alpha times sine theta. And then this can be further written as sine alpha times r cosine theta plus cosine alpha times r sine theta. Now again, we can use the relationship here to express y prime in terms of alpha and the coordinates of A. We change this to, we'll write this as x and this as y, dot sine alpha dot x times x plus cosine alpha times y. So in principle, we have solved the problem. So we have obtained the expression for both x prime and y prime in terms of the angle alpha and the coordinates of A. Now, now from here, you can plug in the actual value of x and y to determine the values of x prime and y prime. And that is, since x equals 1/2, y equals 1/2 of the square root of 3, and then we can write x prime and y prime equals 1/2 cosine alpha minus square root of 3 over 2 times sine alpha. And then the y prime coordinate is 1/2 sine alpha plus square root of 3 over 2 times cosine alpha. And that is the answer for part 2. Now, if you want to get the answer for part 1, all we have to do is to replace alpha with 90 degrees. I'll leave that for you to do that. So that will conclude the active rotation problem. I hope you enjoyed the video. Bye-bye.